Hello guys and welcome back to another video tutorial series on searching algorithms. And today we're gonna discuss on one more technical interview question, and that is, given a circular sorted array of non-duplicate integers, we need to find out the number of times the array is being rotated. Which means that over here you can see that the given array is being rotated 4 times, because the initial state of this array being a circular sorted array, it is like. So this was the initial state of this array, but we are rotating this corresponding array for 4 times. So on the first iteration of this rotation, the last element from here will move to the first. So there is an anti-clockwise rotation of this array. So after the first step of our rotation, our array will look something like this. Now on rotating this array for the second time, the element 10 will come to the first, and there will be an anti-clockwise rotation of each and every element. So at the end of 4 rotation, our array will look something like this given array. So over here you can see there is 4 places of shift for this given sorted array. And our problem statement says that given a circular sorted array of non-duplicate numbers, we need to find out the value of k, means the number of times this array got rotated from its initial state. So over here also I will be giving 2 solutions. One is the brute force approach and second is the optimal solution. But before I give the solution to this question, I would highly recommend you to pause this video and think about the solution of this problem. So hopefully you have got some sort of solution to this problem. If not, don't worry, we will be solving this problem in great detail. So without wasting much time, let's start solving the problem of finding the number of times the given array is being rotated. So before jumping into the solution of this problem, let's first understand the problem and try to observe some of the behavior of this array so that it will be easy for us to solve this problem. So over here you can see the problem statement already tells that there is no duplicate element provided in this array, as well as the given array will be in the sorted order. So given these 2 property over here, we need to find out our solution in the most optimized time. So over here, if you look into this array carefully, you can see that there is a particular behavior that is associated with this corresponding arrays. So over here, this being the initial state of the array, all the numbers given are in a sorted order, that is in an increasing order. Whereas after the first iteration, that is the first rotation, the last element over here got shifted to the first position of this array, since the rotation is taking place in an anti-clockwise direction. Similarly, on the second iteration, that is on k equal to 2, our array will look something like this. So the element 10 will be at the front because that was the last element over here, and then comes the rest of the element present over here. So if you look into these 2 arrays carefully, you can see that there is a particular property that is associated over here. That is, the first element of our initial sorted array is getting shifted 2 position from here, and over here it is shifted 1 position, because over here, since we are rotating this array for 1 times, the first element is getting shifted by 1 place. And since the initial array is in a sorted order, so the element that is the first element of this list should be the minimum element over here. So if you look into this array carefully, you can see the minimum element of this array is 1. And the position of this minimum element is 2 places away from its initial position, means the array is rotated twice over here. Similarly, if you look into our given example, you can see that the smallest element, that is 1, is present 4 steps away from its initial position. And that is why we can conclude that this given array is rotated 4 times from its initial state. So I think you got the initial idea or the approach of solving the problem. So the first thing we need to see in a given array is the position of the minimum element present over here, because the minimum element will give the actual value of the total number of rotations this array has been encountered. So with this fundamental concept in mind, we will solve this given problem statement. So let's start solving this problem using our brute force approach. So the brute force approach of solving this problem is pretty easy and simple if you understand this basic concept of finding the minimum number. Because the main concept of solving this problem is we need to find the position or the index value of the minimum element within this array, because that will give the correct answer to our problem, the total number of times this array got rotated. And using the brute force approach, the easiest way of solving the problem is like we will do a linear search on this array to find out minimum number over here, and we will get the index of that minimum number, and that index will be our desired solution. So let's name the function as finding number of rotation. And over here we will be passing the entire array given to us. So the first thing that we have to say, to get the position of the minimum number, we need to assign a variable called as position and a variable to find the minimum number. And then we will do a normal iteration over this given array to find out the minimum number present over here. And once we find out the minimum number in this array, we will also capture the position of this minimum number, so that at the end of the function we can return that corresponding position from our function, which will be our required output. So here you can see that the solution of this problem using a brute force approach is pretty simple and easy. So what we are doing is like we are iterating a loop from I equal to 0 to the length of this array, and on each and every element we are checking that whether the value we have over here is less than mean or not. If it is less than mean, we are updating the value of the mean and we are updating the value of its corresponding position. So at the end of this total iteration, we will get our minimum number within this array along with its position. And thus at the end of this function, we are returning the corresponding index of the minimum value, because this will give the total number of time this sorted array is being rotated. So over here you can see that the complexity of this problem is order of n, since we are iterating this complete array for once. But over here if you see, we are not utilizing this two property efficiently. That is, the array is in sorted order and there is no duplicate element in the array. So using this two property, we can actually solve this problem in a much more efficient manner, and we can optimize our solution from order of n to order of log of n. So let's see how we will solve this problem and how we will decrease our complexity from order of n to log of n in the more efficient manner. So let's move to our next solution, that is solving the same problem statement in an optimized way. So in this solution, we are planning to solve this problem in an optimized way with a complexity of log of n. So always keep in mind that whenever I am telling that we will be solving the problem is log of n, means we have to think that how we can solve this problem using our simple binary search method. So as I've already told you that there is a particular property that is associated with this given array. Number one is like there is no duplicate element within this array. Number two, the given array will be in a sorted order. And the third point that we have concluded is like we have to find out the minimum number over here to find out our desired solution. So keeping in mind these three properties, we will be modifying our binary search algorithm so that we can get our desired solution in the optimized time. So if you noticed over here, the minimum number that is present over here is 1, and a quite obvious property that is associated with this minimum number, because this array being sorted and circular, that is, the element that will be on the left will always be greater than this element, and also the element on the right will also be greater than this element, because this element being the minimum within this array. So both its neighbor element will be more than this corresponding element. So using this property, we will be finding out the minimum number within this circularly sorted array in the most optimized time. So what we will be doing is like we will be setting up two pointers, one as a left pointer and another as a right pointer, and we will calculate the corresponding middle number from this left and the right pointer. So in this case, the middle element lies over here, that is element number 11. And after calculating the middle element over here, we will compare the corresponding value of the middle element with its corresponding neighbor element. That is the element previous to this middle element and the element that is next to this middle element. So if both the previous as well as the next element are greater than that of the middle element, then we can conclude that this middle element is the minimum number within this array. So over here you can see that for the element 11, the element that is previous to it, that is element 10, is not greater than that of 11. Similarly, the element that is on the right is also not greater than that of the 11. So we can conclude that this is not the smallest number within this array. So after checking this property of the middle element, and if this condition doesn't match, then the next condition that we have to check is like whether the element on the left hand side over here is smaller than that of the middle element or not. So if the element on the left hand side is smaller than that of the middle element, we can conclude that this subarray present over here on the left hand side of this middle element is in correct sorted order. So at that time we have to check the corresponding right hand side subarray. So over here you can see that the middle element is greater than that of the rightmost element. So this right hand side subarray is not in initial sorted order. And since the element on the right hand side array or present over here is less than that of the middle element, we can easily conclude that the minimum number present within this array should be on the right hand side subarray, and thus we will change our lower pointer from position 0 to mid plus 1, that is over here. And in this way we will keep on iterating this array until and unless we find the middle element where both the neighboring element, that is the previous element, and the next element are greater than the middle element. And in this way we will find the minimum element on this given array in log of n time. So I think the basic idea of solving this problem is clear to you. Let's understand this complete solution in detail using our visual display board so that it will be much more clearer to you and you can easily write the code for implementing this given problem. So let's understand the solution using our visual display board. So our problem statement says that given a circularly sorted array of numbers, we need to find out the total number of times the array is being rotated from its initial stage. So to solve this problem in the most optimized manner, we will be using the concept of binary search. So over here also, to solve this problem in log of n time, we will be applying the modified binary search. So to apply the modified binary search, the first thing that we have to do is like we have to set two pointers, one as the left pointer and another as the right pointer. The left pointer pointing to the 0th element of our array and the right pointer is pointing to the last element of our array. And after setting the left and the right pointer, the next thing that we have to do is like we have to calculate the middle element over here. So in this case, element 11 is our middle element. Now once we are done with the initial setup for iteration, now our main intention to solve this problem is we need to find the position or the index of the minimum number within this array. So the first step that we will do over here is like we will take our middle element and we will try to figure out the previous and the next element of this middle number. So over here, since this is a circular array, the way of searching the middle and the next element is somewhat different. So over here we are searching the previous element like mid minus 1 plus n module n. This will give the exact previous element of the middle number. Same thing for calculating the next element, we are computing mid plus 1 module n. Because in this case, if you notice, if our middle element is at the last of the array, then our next element will be the first element of our list. And that's why we need to calculate the previous and next element in this way. So the condition to check that whether the middle number that we have found out over here is minimum or not is that both the neighboring element, that is the previous and the next of the middle element, should be greater than the mid element. So over here we will first check that whether the previous element is greater than mid or not. Also we will check that whether the next element is greater than the mid element or not. So in this case our mid element is 11 and we can see that both the previous and the next element are not greater than the middle element. So we can conclude that this middle number, that is 11, is not the minimum within this array. Now since we got this conclusion, now the next thing what we have to do, we have to calculate the right subarray where we need to iterate. Means we have to understand that whether our minimum element lies on the left subarray or on the right subarray. And to find out that where the minimum element lies, we will check that whether the element on the right hand side is greater than the mid or not. So if the element on the right hand side is greater than that of the mid element, we can conclude that the array on the right hand side is sorted in the increasing order, which means our minimum element will lie on the left hand side. But in this case, you can see that the right hand side value is smaller than that of the middle element. So this condition also fails, which means our minimum element should lie on the right hand side, and thus we will change the left pointer to mid plus 1, and again we will compute the middle element over here. Similarly, over here again we will try to find out that whether this corresponding previous and the next element, that is the neighboring element, is greater than the middle element or not. So over here also this condition doesn't satisfy. Then the next check that we will be doing is like we have to find out correct subarray where we can have the minimum number. So over here we will first check that whether the element on the right hand side is greater than the mid element or not. So over here we can see the value on the right hand side is greater than that of the middle element. So this condition satisfies, which means the subarray on the right hand side is in perfectly sorted increasing order. So our minimum element should lie on the left hand side, and thus we will again change our pointers to the fourth element of our list. And over here again we will check the same condition, and over here this condition satisfied, and thus we will send the corresponding index value or the position of this minimum number. And you can see that the total number of rotation this array encountered is 4, and thus we got our solution in log of n time. So I hope the way we have solved this problem is quite simple and easy to understand. If you have any doubt, please rewind the video and try to understand it one more time, so that it will be very easy for you to implement the code. So let's move to the implementation of this algorithm using our Java code. So I hope now it is pretty much clear that how we are planning to implement this problem. So let's start with the implementation of this above problem using our Java code. But before that, I will highly recommend you that if you like this video, don't forget to like it, and if you are new to this channel, don't forget to subscribe and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So let's start with the implementation of finding the total number of rotation in a circularly sorted array. So let's name this function as find rotation count. And over here also we will be passing the entire array as our parameter. So the first thing that we have to set is we have to set the left and the right pointer over here. And once we are done with setting the two pointers over here, we need to start our iteration on this array. So to make this algorithm much more optimized, the first condition that we will be checking that whether the given array is already sorted or not, means whether there is zero number of rotation or not. Because at that time this will be our minimum number, because the entire array is in sorted array with zero number of rotation in it. Now we will start our main iteration. So the first thing that we need to do is like we need to compute the middle element over here from the left and the right hand side pointer. So once we are done with computing the middle element, the next two things that we have to calculate is we need to calculate index of the neighboring element, that is the previous and the next element of this middle element. So now since we are done with the initial setup of setting the left pointer, right pointer and finding the previous and the next pointer of the middle element, now we can write our first check, and that is whether the neighboring element of the middle element is greater or not. So this means we got the desired index of our minimum number, which is our required solution. Otherwise, if this condition doesn't satisfy, we need to find out the correct subarray where our minimum number can reside. And thus we are done with our iteration, and at the end we will return -1, means invalid input. So this is pretty much the entire code to find out the solution of our problem. So over here you can see that the complexity of our problem is log of n, which is much more optimized than our brute force approach where we have solved the algorithm in log of n times. So I hope you have understand the solution. If not, please let me know in the comment section below. And don't worry about the code, I will share the entire code in the description below. Also for your benefit, I will be sharing one more important document link in the description where I will list down all the top technical questions that you need to prepare before going to any technical interview. So hopefully you have liked this video. Don't forget to like and share the video. And if you are new to this channel, I would highly recommend you to subscribe to my channel and hit the bell icon so that you never miss an update or some important question from my side. So see you on the next video where we will be solving one more top interview question that you can easily come across in your next interview. So see you on the next video. Thank you.